About routing protocols, and the routing protocols, so far we discussed about distance vector routing, and then the other technique is link state routing. Now both are the techniques are for intra-domain routing. Intra-domain routing is a routing which is done inside the autonomous system. So OSPF packet can be sent in 5 scenarios. In the case of RIP, when we discuss RIP, every time we are sending only one kind of packet, but in the OSPF, 5 different kinds are possible. Hello packet, data description packet, link state request, link state update, and link state acknowledgement. OSPF packet can be sent for 5 different purposes. You can use the packet to say hello, you can use the packet to say database description, you can use it for request, update, or acknowledgement. So for all the 5 cases, when you make a packet, some part is common for every packet, and this part is called common header for everyone, and this is of 24 bytes, we already discussed. Now coming to the hello packet. So we have 5 different categories. One is hello packet, then we have database description, we have request, update, and acknowledgement. So hello packet is actually initially when communication starts, means when router want to share the information with other routers, so it will send a hello packet. So hello packet is only shared with the neighbors. Update packet is actually shared with every routers. It is a flooding. Hello packet is not a flooding, it is only shared with the neighbors. Router want to know who are their neighbors, what is the status. This actually wants actually get to know by this packet. So when any router becomes a part of internet, it will send a hello packet. Type is 1, hello. Network mask, to which network this router is a part. Hello interval, it will tell us one value that after how much interval I will ask you hello message. I will check you that you are alive or not. After 20 minutes, I will say hello to you. Okay, just to check your status, you are up or down. E will tell us is this router is a stub router. T will tell us how many services are defined to this router. Priority, also router will announce what is the priority, because we discussed that based on the priority, we need to check the designated router, right? So it will based on the capability. Now we have many parameters are there. Based on that parameters, priority is determined, and that value is written here. Dead interval tell us that after how much time we will assume each other as a dead. So let's say we mutually agreed 10 minutes is the time of hello interval and 30 minutes is the time for dead interval. Means if I did not hear from you in 30 minutes, I will assume as a dead. Then this is only used when we are talking about the transient link or a stub link. So hello packet is initially delivered to all other. For example, this is a router. It connects to one point to point, one let's say stub. So it will send a hello message to both of this connection, get the status, and then whatever the information it collected, it make a link state packet and deliver to flood this to every other routers. This is called hello packet. So it is used to create the neighborhood relationship and also to test the reachability of the neighbors. So before the actual update packet can send, this packet is actually used to get the initial information. Then database description packet, this is another kind of packet which is used to give the picture of the routing table. So there is a possibility one router may be a new of any internet, or maybe it becomes faulty and again it will revoke, it again become a part of internet. So maybe router lost all the information, all the table information. So it may request to other routers, provide me the information. So as a reply, the router will send this database description that this is the status I am maintaining, you also update it. So what are the field here? So this is type 2. E is for the, is this a stub area router? B is this a border area router? If the value is 1, it is yes. Now this database is maybe large and it can be delivered in many packets, in many communication. So I means is this an initial packet? If it is 1 means it is an initial packet. It is a 0 means it is not an initial packet. So 1 means, is this the first message I am sending you regarding the request? M, if it is M is 0, that means this is the last packet. I don't have more information. If M equals to 1 means I have more information. What does it mean? Database may be larger and it is not possible to send the entire information in one message. So it will send in 2 parts. So when it sends in 2 parts, it will keep M equals to 1. That this is not the last message. I will sending you more. Now when they start sharing this information, they will keep work in a master-slave fashion. One will be the sender and the other will be the receiver. So one who sends this information will become the master. One who receives becomes the slave. So they need to mention that I am acting as a master or slave in this field. Every message will be provided one sequence number so that the data which is delivered must be properly put in order. And then this is the header field. So this is the database description packet. So it is used when the system, any router comes in the first time, or it needs some information about the database. Now, link state request packet. Request packet is a scenario when a router is interested to know about the entire table, about the entire structure of the internet, or maybe for some information. So in that case, it will send a request packet. Request packet is type 3. Here this we already discussed. Now what kind of request you are looking for? You are looking for the network request, link request, router request. Based on that, these values are filled. We already discussed this part. And who is sending the request will be here. Now this request can be sent together also, so you can repeat this. Request 1 information, request 2 information, and so on. And then acknowledgement is the simplest one. There is no extra field. You have to simply write the common header and the common advertisement header. So this is the acknowledgement. So these are the 5 different packets actually used in the OSPF. Out of 5, the 4th is the most important, which do advertisement. Other 4 packets are not doing advertisement. Advertisement means it is a flood operation, flooding. Other operations are simply sent to the neighbors. So this is all about this routing.